Okay, this week we are going to begin a huge topic in Algebra 1, factoring. And that's why I have it underlined here where it says factoring quadratic trinomials. That sounds kind of complicated, and it is a little bit, I'm not going to lie. This is one of the, probably the biggest topic that we'll spend the most time on in this entire curriculum is factoring. I would plan for about the next 2 weeks actually. We're going to be exploring this concept of factoring, what it means to factor, and how do we factor. And what our goal for today's lesson is to take a trinomial like this. We saw a bunch of these last Thursday. This is a quadratic trinomial. Quadratics is a fancy word, simply meaning it has a highest exponent of 2. Don't worry too much about that for right now. It's just a technical term. And it's called a trinomial because there are 1, 2, 3 terms. There's 3 of them. It's a polynomial that has 3 terms. It has a highest exponent of 2. Therefore, it is referred to as a quadratic trinomial. But let's take a step back here. Before we look at something like this, let's understand what this word factoring means. Factoring is a really simple concept, actually. It just means to divide a number or a quantity into its constituent parts. For example, the number 6. Let's start super simple here. The number 6 can be factored into, for example, 2 and 3. Right? It can be divided into those two things. The factors 2 and 3 multiply to give us 6. So 6 in factored form is just rewritten as 2 and 3. The number 21 can be factored as 3 and 7. Right? So those are just, and then this could be factored, like, for example, 6 can be factored in a number of ways. You could factor it into 1 and 6. You could factor it into 2 and 3. 21 can be factored into 3 and 7. 25 can be factored into 5 squared, right, or 5 times 5. So all it really means is to take a number, take a large quantity, and to find out what numbers make it up, what numbers multiply to give us that value. Now, we actually did this in reverse order last week. So we started by taking two binomials, right? And we took expressions like y plus 2 times y minus 3. And we saw that when we multiply two binomials, the answer is oftentimes a trinomial. So just kind of a real quick review here, right? I multiply the first terms here, y times y gives me y squared. I distribute to the negative 3, I get negative 3y. I take the 2 and multiply it times the y, that gives me plus 2y. And then we finally distribute the 2 to the negative 3, and that gives us negative 6. And then we simplify this expression, and we get y squared minus y minus 6. And that was our answer in simplest form. So if you think about what we just did here, we multiplied these two binomials, and we got a quadratic trinomial. So what we're going to begin focusing on this week is reversing this process. How do we do this backwards? How do I take a quadratic trinomial and rewrite it as a product of factors? How do I find out what binomials make that trinomial up? Okay, so we're going to look back at that first example now, the one I had up at the top of the slide here. T squared plus 8t plus 12. Well, how do we factor this? Now, there's no way to just kind of look at it and do it at face value. There's no obvious answer just by looking at it. But there is, nevertheless, a simple mathematical formula that we can follow to factor any trinomial that has a leading coefficient of 1. Now, just to kind of restate that, to factor a trinomial with a leading coefficient of 1, find factors of the third term. Factors of the third term that have a sum equal to the second term. So in other words, we are looking for factors of 12 that have a sum of 8. Another way they say this is that there's 3 terms here, right? And we call those terms A, B, and C. So we are looking for factors of C that have a sum of 8. Now, this one, you'll get the hang of this to start doing this mentally, but let's actually list some factors of 12 here. Okay, well, there's 12 and 1, right? 12 times 1 is 12, but 12 and 1 add up to 13. 12 plus 1 equals 13, not 8, so that's no good. I could do 3 and 4, right? 3 and 4 have a sum of, have a product of 12, but they have a sum of 7. So we're one off there, aren't we? Well, that's just not going to quite work, because we still haven't got to 8 yet, right? I could also try, you know, -3 and -4. Well, -3 and -4 have a product of 12, don't they? -3 times -4 is positive 12. But once again, we're not getting any closer because that has a sum of -7. Well, there's still a pair. You may have figured it out already. The pair that we're looking for is 6 and 2. Okay, 6 and 2 have a product of 12. 6 times 2 is 12. 6 plus 2 equals 8. So we have a bingo. So our answer then, the way we rewrite this, is we'd say that this factors into t plus 6, because one of my factors is positive 6, t plus 6 times t plus 2. And if you wanted to test this, you could go ahead and multiply these two binomials again, just like we did last week, and you would get this answer right here. It would come out to t squared plus 8t plus 12. But if you follow this simple process where we find factors of c that have a sum of b, it'll always come out and give us the factored form. Okay, so let's just look at one more for now. This is, by the way, I'm not expecting you to completely understand this by the end of this video or anything. Think of this video as more of a reference for when you get stuck later. Okay, so here we go. We have the trinomial x squared plus 2x minus 8 has a leading coefficient of 1. So that means I can use this method. I ask myself, okay, factors of -8 that have a sum of 2. Because this is our b term, -8 is our c term. So let's just start listing factors of -8. Okay, here we go. Do it off to the side. -8 and 1. Okay. -8 times 1 is -8, right? Those are factors of -8. But does -8 plus 1 add up to 2? Well, no, it doesn't. Okay, let's think of another one here. What about -4 and 2? Okay, -4 and 2. These are other factors of -8. -4 times 2 is -8. But does -4 plus 2 add up to 2? Well, no, it doesn't, right? Now, it adds up to -2, which is kind of a hint. That means we're getting close. -4 plus 2 is -2. That's not the answer, but what it does mean is that we're very close to the answer, which is +4 and -2. If I just switch the sign here, okay, 4 plus -2 does equal +2. So bingo, we have found our answer. And how do we write this? Well, we just take that variable, x, so we're going to write x plus 4 and x minus 2. And I'm writing +4 because +4 is one of our factors. I'm writing x minus 2 because -2 is the other factor. And once again, I won't go to the trouble of it, but you could multiply here. You could go through the whole process of multiplying, and it would give you this original answer, x squared plus 2x minus 8. Okay, so this is what we're going to spend a lot of time doing today. These are just some preliminary notes for you to go by. Much more to come.